So for today, we will have section 3.1, solving linear equations. So we'll have two parts for today's lecture. The first one is uh, the theory and some examples in solving linear equations. And then the second part will be some applications. So we will be working on actual word problems, and we will try to solve those word problems using the concepts that we will learn in the first part. Okay, so what is an algebraic equation? So we begin with the definition of this algebraic equation. Okay, um, if p of x is an algebraic expression in one variable, okay, so this algebraic expression can be polynomial, can be a linear expression or quadratic expression. It can also be rational expressions, can also be complex rational expressions, and even radical expressions. Okay, so if p of x is an algebraic expression in one variable, here the variable is x, then the statement p of x equals 0 is called an algebraic equation. Okay, so algebraic equation is defined, particularly equation is defined by the presence of the relation equal sign. Okay, so we have an expression on the left hand side of the equal sign, and there is another expression on the right hand side of the equal sign. Then what we have is an equation. Okay, so for algebraic expression, what you have there are some products and sums or difference or quotients of variables and coefficients or constants. Okay, so those are the only objects that you will see for an algebraic expression. Whereas you will say you have an equation, particularly an algebraic equation, if you have an algebraic expression and there is an equal sign, and there is another algebraic equation, algebraic expression on the other side or after the equal sign. Okay? Now, if a is a number satisfying this equation, p of a equals 0, meaning we found some number a, and if we substitute it to x in here and we still have the equality, okay, we say that a is a solution of the equation p of x equals 0. So again, in this equation, x is a variable. It can take any number. Okay, it can have any number. But if you found a number such that when you plug it in, okay, when you plug it in, meaning you replace x with that number and the equality holds, then the number that you got is a solution to the equation. Okay, now if you collect all those possible a's, okay, you collect all those possible a's, and all of those a's are solution to the equation p of x equals 0, then what you have is called a solution set of the equation. Okay, so the collection of all real numbers x satisfying p of x equals 0 is called the solution set of the equation. Now, I want to emphasize that we will only be dealing with real numbers. Okay, real numbers. So there is a bigger set of numbers, but we are not going to discuss that in this course. So all our solutions, okay, all our solutions will only be in the set of real numbers. So there's a possibility that um, you will find a certain number which still satisfies the equation p of x equals 0, but that number is not a real number. Okay, there is a possibility that you can find that if you are advanced or if you remember that topic in your previous math courses. So in this course, we will only be dealing with real numbers. Okay? Now, if no real number x satisfies p of x equals 0, okay, meaning we cannot find any real number satisfying the equation, we say that the equation has no real solution. Okay? So the equation has no real solution. Okay? Now, two equations are said to be if equivalent if they have the same solution set. Okay? So in this particular lecture and in the succeeding lectures, we will have several equations which are equivalent to each other. Okay? And they are equivalent by means of this statement, meaning they have the same solution set. Okay? But there are times where one equation is easier to solve. Okay? I am introducing the word to solve or the phrase to solve. So there are some equations which are easier to solve than the other equations. Okay? But if these equations are equivalent, meaning they have the same solution set, then we only work on the equations which have easier methods. Okay? So two equations are said to be equivalent if they have the same solution set. Okay? So now the phrase that I just introduced, so to solve an equation, it means to find the solution set of the equation. Okay, so when we say solve the equation, we mean we want to find all the solutions of the equation. So find the solution set of the equation. Okay? Now, when solving an equation, the following properties are helpful. Charan! So first, we have the reflexive property. Okay? So this means for any real number a is equal to itself. So reflexive, it's a reflection of the number. So 1 is equal to 1, 0 is equal to 0, 2 is equal to 2, etc. So a is equal to a. That's the reflexive property. Okay? Now, we have the symmetric property. And this means that if a is equal to b, then b is equal to a. Okay? So if a is equal to b, then b is equal to a. Okay? So you can think of this as, say, maybe Alice and Bob are siblings. Okay? So A, Alice, B, Bob. Okay? So Alice is a sibling of Bob. Okay? And then that means Bob is a sibling of Alice. So if we use the equality to represent that sibling relation, okay? So you can think of that symmetric property that way, okay? Now, transitive property. So if A equals B and B equals C, then A equals C, okay? So if A equals B, B equals C, then A equals C. Okay? So let us think of, again, possible scenario. Okay? We again use siblings being the equality here, the equal sign. So maybe we can say A is a sibling of Bob, or Alice is a sibling of Bob, and Bob is a sibling of Charlie. Okay? Then Alice is also a sibling of Charlie. Okay? So they are related by brothers or sisters. Okay? So that's transitive property. Okay? Now, we have the following property here, the zero product property. Sorry for that alarm. Okay? So, the zero product property. So, what is this property? So, if you have the product AB and that product is equal to 0, then either A equals 0 or B equals 0 or both of them are equal to 0. Okay, so if you have a product AB and the product is equal to 0, then at least one of them is equal to 0. Okay, now take note of this. This is a property of the zero product. Okay, this is a property of the zero product. Now, I want to emphasize the following because this is a very common mistake. It's very common to students in algebra and even in calculus or in higher mathematics do this mistake. Okay, so sometimes they will find or you will see something like AB, the product AB equals 1. Okay, then these students conclude that A equals 1 or B equals 1. Okay, it's like they are saying there are no other pairs, okay, that will give AB equals 1 but these two pairs. Okay, take note that this guy here, if AB equals 0, then there are no possibilities, but A equals 0 or B equals 0 or both of them are 0. Okay? If the right-hand side is not equal to 0, say like this, B equals 1, AB equals 1, then there are infinitely many pairs that will satisfy this equation. Okay? So do not do this. Okay? Do not just do this. Why? Because, well, I can take A equals 1/2 and B equals 2, right? If you multiply AB, you'll still get 1. Or maybe I can take A equals 3/2 and then B equals 2/3. And if I multiply AB, I still get 1. Okay? So there are infinitely many possibilities for this. Okay? But if the right-hand side is equal to 0, there are only 3 possibilities. A equals 0, or B equals 0, or both of them are 0. Those are the only possibilities. That's why this is a property of the zero product. So please, let me remind you, do not do that to other numbers. Okay? This is only true for the zero product. Okay? Questions so far? Now, let us move to the next property. We call this the addition property of equality. Okay? So suppose we have A equals B, then for any number C, whatever number C is, you have A plus C equals B plus C. So meaning if you add something on the left, you must add the same thing on the right to retain the equality. Okay, so if A and B are equal, what you added on the left-hand side must be added to the right-hand side so that the equality is preserved. Okay? And then similar to property number 5 here. We have property number 6, multiplication property of equality. So if A equals B, then the product AC equals the product BC, whatever your C is. Okay? Whatever your C is. So meaning, whatever you multiplied on the left-hand side of the equation must be also multiplied to the right-hand side of the equation to preserve the equality. Okay? To preserve the equality. Okay? Question. Okay? So now, you might ask, sir, there is addition property and multiplication property of equality. What about the subtraction and the division? Okay? So let me just give the following explanation. So originally there are only two operators, okay, in this system, the real number system or even in other system. In a mathematical system, we can always define these two operations or operators. So addition and multiplication. So what about the subtraction? So your subtraction, A minus B, this is defined as the addition of A with the negative of B. Okay? So if you have a real number B, there's always negative B. You have 1/2, there's always negative 1/2 in the set of real numbers. Okay? If you have 10, you have negative 10. If you have negative 5, you have negative of negative 5. But negative of negative 5, that is positive 5. Okay? So, subtraction is defined as follows. So, A minus B, this is defined as A plus the negative of B. Okay? And similarly, A divided by B, provided here B is not equal to 0. Okay? Provided here B is not equal to 0. This is defined as A times 1 over B. Okay? So if B is not equal to 0, okay, then B will have a reciprocal. You get 1, the reciprocal of 1, it's also 1. You get 2, the reciprocal of 2, it's 1/2. You get 1/2, the reciprocal of 1/2, it's 1 over 1/2, and that's equal to 2. Okay? So you can always get that. So the division can be defined as follows. A times the reciprocal of B if you have A divided by B. Okay? So meaning, subtraction and division, they can be defined using these two operations, the addition and the multiplication. So that's the reason why we don't have those additional names like the subtraction property of equality and the division property of equality, because the subtraction property of equality is already under the addition property of equality, and the division property of equality, it's already inside the multiplication property of equality. Okay? Okay? So now, what we're going to do later is to use this algebraic these properties in solving algebraic equations. Okay? So, for now, let us consider what we call the linear equation in one variable. So, remember the linear expression. Okay? The linear expression is of the form ax plus b. Okay? Now, the linear equation in one variable, say the variable x, this is an equation that is equivalent in the form or equivalent in form to the following equation. Ax plus b equals 0. Okay? So this ax plus b, it's a linear expression. And then we have equals and then 0. So this becomes a linear equation, okay? Where A and B are real numbers and A not equal to 0, okay? A not equal to 0, okay? Of course, the linear equations that we will be working on later in the examples are not written immediately in this way, okay? Not written immediately in this way. So either we rewrite the linear equations later in this form, okay? So that we can solve the linear equation in the original form, okay? And by that, from the original form and rewriting it this way, meaning the original form is equivalent to the form that we will obtain in this way or in this form, okay? Now, suppose we are able to write the linear equation in this form. So the question is, how do we solve this linear equation? Well, the solution to the equation ax plus b equals 0, where a is not equal to 0, is x equals negative b over a. Okay? So this is the easiest equation to solve. Okay? If your linear equation is in this form already, then the solution will just be negative b over a. Okay? So let me give the step-by-step process from this form going to this form. Take note, this is also a linear equation, except that the variable x is isolated on one side of the equation, and the variable y is, and the constants are isolated on the other side of the equation. But this is still a linear equation. And this equation here is equivalent to this form. Okay? So I mentioned earlier, we will have some linear equation. We will transform it to this form. And then from this form, we will be able to transform it to this form. Okay? But in actuality, when we are going to solve the linear equations that we have, what we're going to do is from the original problem or original linear equation, we will work so that we will go directly to this form. Meaning, we will work so that we have the solution already afterwards. So meaning, we will skip this particular form. Okay? Now, from this form, ax plus b equal to 0, how do we get this x equals b equals negative b over a? So again, I'll show you the step-by-step computation. So we start with ax plus b equals 0. And what we're going to do is to abuse all the properties that we um, listed earlier. Okay? So again, this is a step-by-step process, so do not be surprised. Okay? So we start by adding. So we started from here. What we're going to do is to add or subtract b on the left-hand side of the equation. But the addition property of equality tells us that we should subtract b on the right-hand side of the equation also. Okay? Now, if we look at this, we have, so let us extend that. So we have plus b minus b. We know that this is equal to 0. Whereas 0 minus b, this is equal to minus b. Okay? So these two guys here, Okay, these two guys here are actually um, properties of the number 0 or the negative of a given number. Okay, so these two are properties. Okay, but what's the point? If b minus b is equal to 0, then we'll just have ax plus 0, and then the other guy will just have minus b. Okay, you'll just have minus b. And then again, similar to this property here, ax plus 0, um, it's just ax. Okay, ax, and this is equal to negative b. Okay, now since a is not equal to 0, okay, since a is not equal to 0, then okay, we will have 1 over a. So a not equal to 0, this means that we have 1 over a. Correct? This is the reciprocal of the number a. So this one here, it's the reciprocal of a. Okay, reciprocal of a. But more formally, this is known as the multiplicative inverse of a. So multiplicative inverse of a. Okay? Or simply the inverse of a. Okay? Now, I did not mention this negative b is actually called the additive inverse of b. Okay? Negative b is called the additive inverse of b. Okay? But anyway, we have 1 over a as the reciprocal or as the multiplicative inverse of a. Okay? So what we can do is to multiply on the left, okay? Multiply on the left hand side of the equation, 1 over a, and at the same time, so that we can preserve the equality, we have to multiply 1 over a on the right hand side of the equation also. And these two guys here, if you multiply a with 1 over a, that will give you equal to 1. Okay? That will give you equal to 1. So that on the left-hand side, you will just have x, whereas on the right-hand side, remember, I defined division as multiplication, correct? In the previous slide, the division is defined as multiplication of something like this. So the right-hand side becomes negative b over a. Okay? Okay? So again, I have mentioned, this is the step-by-step process. Okay? This is the step-by-step process in solving the equation ax plus b equal to 0 to get x equals negative b over a. Okay? Okay? So, when solving linear equations, the goal is to isolate the variable on one side of the equation by using the properties of real numbers and equalities. Okay? So, we isolate on one side of the equation the variables, and then on the other side, the constants. Okay? And we can do that, by using the properties of real numbers and the equalities. Okay? So, um, let us work on these examples. So we want to solve 2x plus 10 equals 7x. Okay? So like I mentioned, we will abuse the properties in this solution. Okay? So from 2x plus 10 equals 7x, what we're going to do is to isolate the variable x, okay, to one side of the equation. And then the constant will move it to the other side of the equation. Okay? And to do that, so from here, what we can do is to add or subtract 7x on both sides of the equation, as well as negative 10 on both sides of the equation. So as you can see in here, I subtracted 7x. I also subtracted 10 on the left-hand side. And then on the right-hand side, I did the same. I subtracted 7x. I subtracted 10. So why is that? I want this 7x to disappear on this side of the equation. So the way is to subtract 7x also. Okay? Also, I want this 10 to disappear on this side of the equation. And the way is to subtract 10. So I'll do that, okay, on both sides of the equation. Okay? So when we do this, next is to simplify. You have 2x minus 7x. That's your 5x in here. Okay? And of course, 10 minus 10, that's just 0. So you can remove the 0. Okay? And then on this side, you have 7x minus 7x. That's again 0. And then you have minus 10. So you'll end up with negative 5x equals negative 10. Okay? And then, when we have this, what we're going to do, since you have negative 5 here, it's not equal to 0, we multiply both sides of the equation by the reciprocal of negative 5. The reciprocal, it's negative 1 over 5. Okay? So, multiplying both sides of the equation by negative 1 over 5, okay, we will have the following. And if we now multiply negative 5 and negative 1 over 5, you'll be left with x. And then on the other side of the equation, you have negative 10 multiplied to negative 1 over 5. You will just get 2 after simplifying. Okay? So, most of the time, we stop the solution on this part when you have isolated x already, especially if your equation is just a linear equation. Okay? Now, you might ask me, sir, can I just, instead of multiplying negative 1 over 5 on both sides of the equation, can I just divide both sides of the equation by negative 5? That's totally fine. That's, again, the definition of your division. Okay? So, it's totally fine if you do that. And in fact, you will see later in the solution, in the next examples, instead of multiplying the reciprocal, I have divided the left hand side and right hand side of the equation by the coefficients of x. Okay? Now, like I said, if you have linear equations, especially this simple form, okay, the solution stops at this point. Okay? However, if you have other forms, okay, if you have other forms, other types of equations, which can be reduced to a linear equations or other types also, you might need to do some checking, okay? So I am going to show the checking part. The checking part is when you have your supposedly final answer or supposedly the solution, okay, to the equation, what you do is to substitute that to the original equation and check whether the equality holds. Okay? So in this part, you have x equals 2. So what we're going to do is to substitute that x equals 2 on the x's that we see in the original equation. And we check if equality holds. So when x equals 2, does left-hand side equal right-hand side? Let us check. So we replace the x with 2, and therefore the left-hand side will be 2 times 2 plus 10. And the right-hand side will be 7 times 2. And indeed, you will see 14 on the left-hand side, 14 on the right-hand side. And therefore, you have the equality. And therefore, this is the solution to the equation. Okay? Okay? So, again, like I said, when you only have linear equations, simple linear equations, just like this, the checking part may not be needed. Okay? Later in the course, I will be explaining that you will need to do the checking part because there's a possibility that the numbers, okay, on the last step, the numbers that you will get may not be an actual solution to the equation. Okay, so I'll explain that later. But for now, at least we know that when x equals 2, the equation is satisfied and therefore x equals 2 is a solution. Okay? Next, we have 3 times 4 minus y equals 2y minus 5. So we want to solve for y satisfying this equation. Okay? So first step, we distribute these 3. Okay? So you will have 3 times 4, that's 12. 3 times negative y, that's negative 3y. That's now the left-hand side. The right-hand side, you have 2y minus 5. And then we continue with our solution. So we want to isolate the y on one side of the equation. Okay, and then we put all the constants on the other side of the equation. So on this step, what I did is to remove this 3y on this side. Okay, and then here, I will remove the constant. So I will remove this negative 5 on this side. So to remove the 3y here, since this is minus 3y, I have to add 3y. In here, to remove 5, we have negative 5 in here. I have to add 5. So we add 3y and 5 on both sides of the equation. And then from here, we simplify things. We will end up with 17 equals 5y. So we have here 12 plus 5, that's 17. Here, negative 3y plus 3y, it's just 0. In here, you have 2y plus 3y, that's 5y. And then you have minus 5 plus 5, that's just 0. That's why we have this. Okay? And then, we divide both sides of the equation by 5. So you see, this time I use division, okay, instead of multiplication of the reciprocal. So it's totally fine if you do the division or the multiplication of the reciprocal. Okay? So on both sides, I have divided by 5 the expressions. So in here, you will have 17 over 5 on the left-hand side. And then on the right-hand side, you have 5y over 5, but 5 cancels each other. So you'll just get y. Okay? Now, by convention, we always put the variable on the left-hand side of the equation. Okay? By convention, we always put the um, the variable on the left-hand side of the equation. So from here, I'm going to use the reflexive property. Remember reflexive. If A equals B, sorry, this is not reflexive. This is symmetric property. Okay? This is symmetric property. So the symmetric property is if A equals B, then B equals A. So in here, I have 17 over 5 that's equal to y. But like I said, our convention will be we put y or we put the variable on the left-hand side of the equation. So applying symmetric property. So again, this should be symmetric. We will have y equals 17 over 5. Okay? So at this point, we have a candidate solution. Okay? But this is a simple linear equation. Okay? Although not in the general form, this is just simple. Okay? So this y equals 17 over 5 will be a solution to this equation. Okay? But let's practice the checking part. So when y equals 17 over 5, does left-hand side equal right-hand side? And if you check, you always substitute the candidate that you have into the original equation. So in here, we replaced y by 17 over 5. Similarly, for this guy here. So if we simplify this, we will have these expressions here on the left-hand side and on the right-hand side, and we will get the equality. They are both 9 over 5. And therefore, indeed, y equals 17 over 5 is a solution to this equation. Okay? Next equation in here, we have 2x times x minus 3 equals x plus 3 times 2x minus 3. So, you have this. What we're going to do is to, well, multiply 2x and x minus 3 and then also multiply these two binomials. So if we do that, we will end up with this expression or this equation. So you have 2x squared minus 6x equals 2x squared plus 3x minus 9. As you can see, both sides of the equation, okay, have squared term. So you might say, sir, this is not linear. However, when you simplify this further, okay, you will end up with a linear equation. So this is still a linear equation. Okay? As you can see, you have 2x on the left-hand side of the equation. You also have you have 2x squared on the left-hand side of the equation, and you have 2x squared on the right-hand side of the equation. So if you have your cancellation law, which you do, okay, this 2x squared on the left-hand side will cancel the 2x squared on the right-hand side. Okay? But to see that in more details, what we're going to do is to add both sides of the equation by 2x squared. Actually, we add the negative 2x squared. So on the left-hand side, you have here negative 2x squared. On the right-hand side, you also have here negative 2x squared. And that will cancel this 2x squared here and in here. And then I want to put this 3x on the other side of the equation. Okay? Meaning I want to remove also this 3x on this side. So I will add negative 3x on both sides of the equation. That's why you have here negative 3x here and also in here. So this negative 2x squared will cancel the 2x squared here. And then minus 6x minus 3x will just combine them. On the right-hand side, we have minus 2x squared. It will cancel the 2x squared here. And then this minus 3x here will cancel the 3x in here. And therefore, on the right-hand side, we'll be left with negative 9. So if we simplify, we have this. Negative 9x equals negative 9. Then we divide both sides of the equation by negative 9. We will have this. And finally, we'll get x equals 1. Okay? So again, this is, well, this is not simple in a sense because you will get some quadratic. But in here, when you have something like this, when you don't have denominators, okay? When you don't have denominators on the equation, especially denominators having variables, okay? You have variables on the denominators. You don't actually need to do the checking part. But anyway, we'll still do it on this part of the solution. So when x equals 1, do we have equality on the left-hand side and on the right-hand side? So in here, you just have x equals 1. So you have 2 times 1 times 1 minus 3. And then for here, you have 1 plus 3 times 2 times 1 minus 3. And you will end up with negative 4 on both sides of the equation. And therefore, you have the solution, x equals 1. Okay? Questions so far? Next, look at this. You have 2x over x squared minus 4 equals 4 over x minus 2 plus 3 over x plus 2. So, in here, you have rational expressions on both on the left-hand side and on the right-hand side. So, you can say that this is not linear equation. This is not a linear equation. Which is true because this actually is a rational equation. But if we manipulate this, we will end up with a linear equation. Okay? Now, here's the thing. You have a denominator in here. You have denominators on here. Okay? And the denominators contain variables. So, because of that, we will have some restrictions on the variable. Numbers that it cannot take. We don't want 0 on the denominators. Okay? So, if you look at this, x minus 2, this will be 0 when x equals 2. Here, x plus 2, this will be 0 when x equals negative 2. And if you look at this, okay, x squared minus 4, this will be 0 when x equals 2 or x equals negative 2. Okay? Which means that we put a restriction. After we solve this, okay, after we solve this, we should not get x equals 2 or x equals minus 2. Because if we get those numbers, then they are not really solutions to this equation. Okay? So for this, let us try to solve this. Okay? If you remember your LCM method, okay, that's what we're going to use. So you check the LCM of the denominators. The LCM will be x squared minus 4 And that can be factored into x minus 2, x plus 2. So what we're going to do is to multiply both sides of the equation by x squared minus 4. And again, x squared minus 4, that's x minus 2, x plus 2. You can only do this multiplication if the one you're multiplying is not equal to 0. Actually, if you're multiplying 0, that's totally fine. Okay? If you are multiplying 0, that's totally fine. And then you will get 0 equals 0. Okay? However, in the next step, we require that this guy here and this guy here or this guy here are not 0. Okay? Because you cannot cancel 0 over 0. That's not even defined. Okay? Therefore, we require x squared minus 4 not equal to 0. And if we do that, we can cancel x squared minus 4 with the x squared minus 4 in here. Okay? And then in here, when we distribute this x squared minus 4 over the sum in here, one of the factors, okay, will be canceled. Okay? So if we do that, we will end up with this expression. So what happened? Again, x squared minus 4 will cancel the x squared minus 4 on the left-hand side. On the right-hand side, when we distribute this x squared minus 4 to this first addend, the x minus 2 will be canceled with this guy here. And therefore, what will remain is the x plus 2. That's why you see 4 times x plus 2 here. Now, when we distribute this to this addend here, the x plus 2 will cancel this guy here. And therefore, what will remain is the x minus 2. That's why you have 3 times x minus 2. So it's the same process when we discuss the LCD method or LCM method. Right? So now, when you simplify this, you'll just end up with linear equation. Actually, this guy here is now a linear equation. So we distribute the 4, you'll have 4x plus 8. You distribute the 3, you'll have 3x minus 6. And then you simplify 4x plus 3x, that's 7x in here. 8 minus 6, that's positive 2 in here. So from here, we isolate. We isolate the variable x. We want to remove this 7x in here. So we'll add negative 7x on both sides of the equation. And this guy here, this does not contain any constant, so we'll not add anything anymore. So adding both sides of the equation by negative 7x, this 7x will be cancelled. And therefore, we will end up with negative 5x equals 2. And if we solve for x, we divide both sides by negative 5, we'll have x equals negative 2 over 5. And take note, the x it is equal to negative 2 over 5. And I mentioned earlier that our restriction is that x cannot be positive 2 or negative 2. And we have that here. Therefore, this is a very good candidate as a solution to this equation. In fact, if you do the checking part, you will get the equality. Okay? So I leave the checking part to you. Okay? So these were this is one of those times that you need to do the checking. Although the checking will be obvious, in a sense that you just don't want the denominators to be 0. Okay? Questions? Any questions? Now, like I said, problems normally do not just ask you to solve a certain equation. They will be given um, or they will be described using words and sentences. Okay, we call them word problems. Okay, so applied word problems do not come in the form solve the equation. Instead, they supply information using words, a verbal description of the real problem. Okay, so to solve such problem, what we're going to do is to translate the information that we have, the verbal descriptions, into mathematical language. Okay, if possible, of course. We call this mathematical modeling. Okay, we call this mathematical modeling. So our goal, you have a word problem and we want to solve that. So we use mathematics to solve that. Okay? These are the suggested steps in solving the word problems. First, of course, you read the problem carefully, more than once if needed. Okay? And then identify what is or are being asked in the problem. Okay? Next, when you know what are being asked, you can now start assigning variables. Okay? These variables should represent the quantities or the units that you have in the problem using the data. Okay? And then, if possible, you write the quantities in terms of one quantity only, if possible. Okay? And then, if possible also, you can draw a diagram. It's easier to solve the problem if you can visualize it. Well, at least for most. Okay? And then you label the unknowns and the known quantities. Okay? And then you write mathematical statements relating the quantities. Okay? Recalling some formulas and identities may be helpful. And in our next lecture, I will supply you with several formulas. Okay? And then you solve for the variables. Okay? You already have the mathematical statements, meaning you have the equations. Okay? You solve the equation. And once you have the solution to that equation, you now answer the questions that are being asked in the problem. And you have to write in full statement, in full sentence. You have to write the conclusion. Okay? Now, things that I want to emphasize, when you assign a variable or when you started assigning variables, you have to give them the names. Not just put X or Y as variables without giving a name. A lot of students do that. They have read the problem, they'll put X, write the equation without giving a name to the variable, and then at the end, um, they'll just have X equals something, and then encircle it, and they do not put the conclusion. So my question is, what if there are several quantities there? What is your X? What is your Y? Okay? It won't give you the actual answers. What if you have an equation, you solve for X, but you are being asked to answer the question related to 2x plus 1? Yes, you have your x, but the actual question is what is 2x plus 1? Translated, of course, to mathematical statement. So you didn't answer the question there. So you have to, when you assign variables, make sure you label them properly. Make sure you give them the name. And then, after solving, you write the conclusion. Okay? So let's try that. Okay? Check whether your answers make sense in the original problem, not just the mathematical statements that you wrote. Okay? You answer the question, you could have checked it against the mathematical statement, but that's not the one you needed. And in fact, for example, um, you are asked to find lengths, you got a negative number. And then a lot of students do this. Okay? Um, Therefore, the length is negative 1. We don't have negative lengths. Lengths are positive. So if you got a negative number, then the solution that you obtained will not make sense in the problem. Okay? And then some students are doing this. Oh, I got a negative number. I have length. It should be positive. So I'll just remove the negative sign. A lot of students do that. And that's wrong. Okay? That would be wrong. So it means that something is wrong with your mathematical statements. So you have to make sure that all the answers that you will get make sense in the actual problem. Okay? So let us consider this. Alice, who is paid time and a half for hours work in excess of 40 hours, had a gross weekly wages of 624 for 48 hours work. What is her regular hourly rate? So the question is, what is the regular hourly rate given this situation? Okay? So let's start. Let X dollars be the hourly rate of Alice. So we now have the problem. We now want the regular hourly rate. We assign a variable to this regular hourly rate. Let X be the hourly rate of Alice. Okay? And what are we going to do with this? Then her overtime rate, it's 1.5x. Okay? Look at this. Alice, who is paid time and a half for hours work in excess of 40 hours. So there is overtime. What is the rate of the overtime? So I have related the rate of the overtime with the rate of the regular hourly rate. It's paid time and a half. That means 1.5. Okay? Now, this is the other information. She had a gross weekly wage of 624 for 48 hours work. Okay? So, let us try now to visualize or to put this information, okay, on a table. We have the column for hourly work, for hours worked, we have the hourly wage, and then the salary. Okay? So for the regular hours, it's just 40 hours. So you have worked 40 hours. That's your regular. The hourly wage will be X. So for these 40 hours of work, the salary will be 40 times the hourly rate. Okay? Now, Alice worked for 48 hours. So there is an 8-hour overtime. So overtime will be 40 minus 40, 48 minus 40, that's equal to 8. And for the overtime, the rate will be 1.5x. So this is your hourly wage for the overtime, 1.5x. And there are 8 hours of that. So 8 times 1.5x, that's 12x contribution to the salary. And therefore, you have all this amount that should be equal to 624. So if you add them, you have 40x plus 12x. That should be equal to 624. 624 is the total amount received for working 48 hours. So now we have a linear equation in here. We just solve for x. So we combine this. This is 40 plus 12. That becomes 52x. Then if you divide 624 by 52, you'll get x equals 12. Okay? So this means we have a candidate. The regular hourly rate of Alice is $12. Let us check. With this rate, 40 hours of work yields a salary of 40 times that $12. That's 480. And for the overtime, you have 12 times 1.5. Okay? 12 times 1.5, that's 18. Then you multiply it by 8 because you have 8 hours of overtime work. You'll get 144. And if you add these two guys here, you will get 624. Okay? Okay? Any questions? Now, next problem. Bob is paid time and a half for hours work in excess of 40 hours and double time for hours work on Sundays. Okay? So paid time and a half for hours work in excess of 40 hours and double time for work on Sundays. If Bob had a gross weekly wages of 627 for working 50 hours, 4 of which were on Sunday, what is his regular hourly rate? So again, you are asked to find the regular hourly rate. So let's start with that. Let X dollars be the hourly rate of Bob. According to this first statement here, Bob is paid time and a half for hours work in excess of 40 hours. So overtime pay without the Sunday overtime, okay, the rate will be 1.5x. That is his overtime non-Sunday rate. And the Sunday rate will be 2x. So you have double time. Following so far? And therefore, we now have these quantities. Let's apply now, or let's now look for the hourly rate with this information. So hours work, hourly rate, hourly wage, and then salary. For the regular, you have 40. Okay? So overtime in excess of 40 hours. So that's your regular hours. So hourly wage is X, salary will be 40X. On Sundays, it said that there are 4 hours. So hours work on Sunday, you have four hours there. And the payment is double time. So hourly wage is 2X. Therefore, the contribution to the salary for this Sunday work will be 4 times 2X, and that's 8X. And then for the other overtime work, which are non-Sundays, you have 50, that's the total working hours, minus 40, that's the regular hour, minus 4, that's now the overtime non-Sunday. So 6 hours. And the rate is 1.5x. So the salary will be 9x for this overtime non-Sunday. Okay? So if we add these three guys here, 40x plus 8x plus 9x, that should give us 627. Okay? So from here, we just need to solve the equation. Okay? You add 40x plus 8x plus 9x, that will be what? 57x. Okay? And then divide 627 by 57, you'll get x equals $11. So the hourly rate of Bob, the regular hourly rate of Bob is $11. And let us check if this $11 makes sense. So the 40-hour regular rate or regular hours, you have 40 times 11, the contribution will be 440. For the Sunday, 4 hours, so the rate is double pay. So instead of 11, you have 2 times 11, that's 22. And you have 4 hours, that becomes 88. And then for the other overtime, 6 hours, you have 11, you are paid 1.5, okay? And then you have 6 hours. And this is equal to $99. So if you added all of them, 440 plus 88 plus 99, you will get 627. So it makes sense. Okay? Questions on this problem? Let's look at this problem. This will be the last problem for this session. So a car dealer at a year-end clearance reduces the list price of last year's models by 15%. If the new price of a certain four-door model is 8,000. So take note, the new price is 8,000. What was the car's list price? Meaning, what was the car's price last year? And how much can be saved by purchasing this model? Okay? So how much can be saved by purchasing this model now compared to purchasing it last year? Okay? So let's start with our problems. What was the list price? What was the price of the car from last year? And how much can be saved? So we can let P be the list price. Let P be the price of the car from last year. Okay? Then, the discount from list price will be 0.15 P. So 15% discount. Okay? So you multiply the price from last year by 0.15. Okay? So we have the list price minus the discount. That will be the new price. Okay, so far? So the list price is P. The discount is 0.15p. So P minus 0.15p. That should be equal to the new price. The new price is 8,000. So we solve for P. So you have P minus 0.15p. That becomes 0.85p. That's equal to 8,000. We solve for P. P will be roughly 9,411.76. Okay? So this was the original price of the car. This was the price of the car from last year. Okay? So the list price is approximately 9,411.76. And what will be the savings? Well, if we purchase the car now, we just paid 8,000, okay, instead of this 9,411.76. So the savings will be 1,411.76. Okay?